Around 66 million years ago, Earth and its inhabitants faced an event that could only be described as Armageddon. When an enormous asteroid the size of Mount Everest slammed into the Yucatan Peninsula, the collision of the asteroid unleashed an explosion with the energy of 10 billion Hiroshimas. This was the moment that brought an end to the reign of many prehistoric fauna. Today, we know it as the KT extinction event. In a blink of an eye, roughly 75% of Earth's species were wiped out, leaving behind a shattered and desolate world. But was this truly the end of a saga that had spanned millions of years? Were these incredible non-avian dinosaurs all wiped out in an instant? After all, how would that be the case if they roamed every continent during the Cretaceous era? When the asteroid struck, there was an estimated 1,000 dinosaur species, ranging from giants over 60 feet long to behemoths weighing more than 80 whole tons, about the size of a commercial airline. And let's not forget, the Earth was teeming with even more monstrous megafaunal species. Extinction events like this leave us with more questions than answers, and the mystery is what keeps us coming back. But first, make sure to subscribe and stay tuned for new videos every Friday. There's always more to uncover about the wild past. If you were looking for the short answer, then yes, the dinosaurs didn't all disappear in a single day. But there's more to the story than you think. Some species demonstrate a remarkable resilience in its aftermath. Fossil evidence hints that isolated populations may have briefly adapted to the changing world. This means that technically, dinosaurs survived in the Cenozoic Era, the time when Earth began to recover and new ecosystems emerged. Dinosaurs in colder climates, or regions less impacted by the asteroid's direct effect, might have survived longer than their counterparts. Paleontologists agree that the extinction of non-avian dinosaurs was a more complex process, involving gradual declines and fierce survival struggles in the aftermath. The asteroid's impact blocked out sunlight and caused global temperatures to plummet, creating a chain reaction that pushed ecosystems to their limits. While some species may have clung to life a little longer in isolated regions, the combination of environmental collapse and dwindling food resources eventually sealed their fate. Within the first 24 hours, most wildlife had perished. This was especially evident in the Western Hemisphere due to an onslaught of devastating events, from raging forest fires, massive blast waves, earthquakes, and devastating tsunamis that had obliterated life within a 1,500-mile radius in mere minutes. But for those who survived the immediate chaos, the nightmare was far from over. The impact hurled up to 25 trillion tons of material into the atmosphere, which eventually rained back down as molten rock, heating the air to temperatures hotter than that of the sun. This fiery fallout incinerated anything out inside the open, igniting wildfires that ravaged about 70% of the planet's forests. But even in this inferno, there were small chances of survival. Some dinosaurs may have sought refuge in marshes or more cooler regions at higher latitudes. These survivors were likely smaller species or juveniles, better suited to hiding and enduring the harsher conditions. Sadly, however, for the remaining dinosaurs, surviving in the short term didn't ensure a lasting future. The fires and ejected debris filled the atmosphere with soot and ash, blocking out sunlight and triggered an apocalyptic nuclear winter. Global temperatures plunged by as much as 20 degrees Celsius, creating a deep freeze that disrupted ecosystems worldwide. Plants withered, food chains collapsed, and even the hardiest survivors couldn't endure the prolonged darkness and cold. This chain of events ultimately sealed the fate of the non-avian dinosaurs, marking the end of their remarkable 165 million year dominance on Earth. The aftermath of the asteroid's impact is a vague period still studied by paleontologists. There is uncertainty about how long it took for the remaining dinosaurs to perish, or whether some managed to survive but never fully recovered. Research suggests survivors might have persisted up to weeks, months, or even years. Carnivores with an abundance of carcasses initially available likely lasted longer than herbivores, whose food sources were obliterated by the fires. While lucky herbivores may have found pockets of surviving vegetation, these resources were only temporary. Once the herbivores perished, the carnivores followed, unable to find sufficient nutrients. One study estimates the extinction process spanned about 15 years long. As airborne dust and debris caused a prolonged nuclear winter, photosynthesis was nearly halted, which lasted for at least 1 full year. Temperatures remained frigid and food chains had collapsed, while other studies reflect a similar but harsher timeline, suggesting the extinction of non-avian dinosaurs occurred within a full century. But whatever the exact duration, it was a slow and agonizing end for the creatures that had once dominated the Earth for millions of years. During this time, mammals began to grow larger, insects thrived, and crocodilians and turtles dominated as the largest animals, a stark contrast to the time of the Age of Giants. Surviving dinosaurs likely faced stiff competition, from evolving mammals to growing reptilians, gradually leading to the decline of the dinosaurs' populations. Interestingly enough, there's evidence which shows over 1,000 generations of dinosaurs might have persisted before vanishing. While it's mostly clear that non-avian dinosaurs disappeared, their evolutionary legacy did persist inside the form of birds, where birds are considered the direct descendants of theropod dinosaurs, a group that includes a species like the velociraptor and Tyrannosaurus rex. Another interesting case includes the crocodilians. Where they aren't dinosaurs directly, they share a common ancestor with them as members of the larger Archosaur group. Crocodilians survived the mass extinction, likely due to their ability to thrive in aquatic environments and enduring harsher conditions, remaining relatively unchanged over millions of years. So in a way, dinosaurs still live with us today through their later ancestors. While crocodilians represent one way the dinosaurs' legacy lives on with us, evidence from fossil discoveries in the San Juan Basin in Colorado and New Mexico points to prolonged survival for some species. Fossils of hadrosaurs, tyrannosaurs, and other species were discovered there, dated all the way to the Pleistocene epoch, a full 500,000 years after the asteroid's impact had struck Earth. This raises a question: how did the dinosaurs survive for so long, and why only in this specific region? Scientists proposed 3 different theories. This area might have provided natural protection, similar to a canyon sheltering life from the asteroid's immediate effects. Alternatively, survivors may have migrated south from Canada to escape harsher conditions. The last theory being is that their eggs perhaps could have endured the catastrophic events, and only hatched after once conditions had improved, allowing for a smaller population to re-establish itself. However, these are mostly speculations where critics argue that fossils may have been reburied in younger sediments, which may have given a falser appearance of their survival. Despite researchers defending their finds, including intact skeletons supporting the timeline, most researchers remain skeptical if these dinosaurs truly endured a post-apocalyptic Earth, or if it was all just a geological mix-up. Some people wonder, what if dinosaurs, including massive ones such as giant sauropods, managed to survive the asteroid's aftermath? Could smaller and more isolated populations have adapted to the harsh post-Mesozoic world? Or would they be limited to preying on other survivors? Or could they have adapted to the new landscapes, perhaps through shrinking rapidly due to scarce resources, much like the dwarfism seen in animals on isolated islands? Ultimately, we don't truly know how long these creatures could have hung around for, but it's a comforting thought that they could have stuck around for a little while longer. Right now, the most recent dinosaur officially recognized by science is a Triceratops specimen that likely died right around the time the asteroid had hit. Some scientists think that it might have even been directly killed by the impact. Whether it was from the heat, shockwaves, or all the chaos that followed, it is fair to say that this particular Triceratops might have been one of the last dinosaurs standing before everything changed forever. This sparked a lot of curiosity about whether other Mesozoic creatures, like Pterosaurs or Mosasaurs, might have hung on for a bit longer. These creatures were insanely adaptable, and even ruled the skies and seas for millions of years, and raised questions on if any of them survived within isolated pockets for a little while longer after the asteroid's impact. These theories show how much we still don't know about what really happened in the chaotic years after the impact. With each new fossil discovery, we get a little closer to piecing the story together, and who knows, maybe we'll one day find the evidence of a few survivors that had defied the odds. Currently, there's no definitive answer, but there's an intriguing theory about a lesser known group from the same era, ammonoids. These marine mollusks, closely related to modern squids and octopuses, were incredibly diverse and widespread during the Mesozoic. Some researchers believe certain species of ammonoids might have survived for up to 1 million years after the Cretaceous extinction event. If true, this would make them one of the few survivors of the asteroid's impact. This idea, much like the debated findings in the San Juan Basin, remains controversial. As the evidence is still highly limited, not many people agree on the interpretations. Still, the hypothesis has gained traction among some paleontologists, thanks to the improved dating techniques and more detailed studies of the fossil layers. If ammonoids did persist, their survival could have offered valuable insights into how some species adapted to cope with Earth's altered environment. The story of ammonoids is just one piece of a much larger puzzle about what had happened after the asteroid hit. With continued research, we can hope for more clarity, and not just on ammonoids, but also on the fate of dinosaurs and other iconic Mesozoic creatures. Thanks for watching, and until next time on our journey into the wild past.